All right. I guess we could get started on this call. All right. Good morning, good afternoon, good evening, wherever you are watching from or joining from. Welcome to another community workshop. My name is Feiji. I am a community programs manager. And I am thrilled that we're talking about virtual threads in Java today. So what are virtual threads? Understanding virtual threads, using them in your day-to-day. How can you do that? That is why we are on this call today. So it's very packed, very informative, and it's something that you could implement in your day-to-day. All right, so without further ado, I'd love to tell you about the agenda. We'll be having an introduction to virtual threads. So if you're like me, who's non-technical, and you're just very curious to know what this is, stick around because we'll be talking about what they are. And then we'll be looking at a problem statement. How has virtual threads solved this issue? And how does virtual threads work? And then our host and speaker for today will be diving into a programming demo where we're showing you everything you need to know about virtual threads. And then how existing code is affected and the do's and don'ts of using virtual threads. And if we have questions at the end, we'll take them. So stick around and let's dive into, virtual threads. Before we start off though, I would love to introduce our speaker for today. His name is Emil. He is a full stack engineer with hands-on back-end experience as well. And he's been instrumental in building back-end solutions in several sectors. Emil comes with a wealth of experience, and this is something that he has utilized in the past. And he's here to, tell you all about virtual threads. So join me in welcoming our co-host and speaker for today, Emil Yakubor. How are you doing, Emil?
Yeah, I'm doing good, Reggie. I'm doing so great.
Awesome you here, and thank you for joining us this afternoon to share your experience on virtual threads. Before I let you take it away, I would love to ask how your experience has been, using Java, and how virtual threads has helped you in your day-to-day.
Yeah, so it's been good. Java has been a fantastic language. With virtual threads, I think after virtual thread was released in somewhere September, which is the final version, the release version of JDK 21. It has caught a lot of eye, and it caught my eye as well. And I have been following the news ever since. Day to day on daily basis, I keep reading about the latest news on it. Yep. And so I can say I'm up to speed and I'm up to date on the JDK 21.
Awesome. So we could throw you all the questions about virtual threads, what type of scenarios we could utilize them, but that will be taken right at the end of this session. So I'll allow you take it away. So thank you so much once again, and I'll let you, go on with this session.
Okay, so thank you, Feji. I think I'll get right in by sharing my screen. Yep. All right, thank you very much. So as Feji already introduced, we'll be looking at virtual threads today. And without wasting much time, let me dive right in. All right, so basically, what are threads and what are virtual threads? Okay, so looking at it traditionally, when you go to the restaurant or the kitchen of a restaurant, or even in your own restaurant, you find yourself doing quite a couple of activities, trying to prepare a particular meal. So you find yourself sliding onion. You find yourself, let's say you end up in the typical restaurant or the kitchen of a restaurant. There's someone who's doing cleaning. There's someone who is sliding onions. There's someone who is stirring the stew and stuff like that. So if you have, so the execution of those individual tasks that I just mentioned out is what we call a thread. Okay, so the activities that are actually going on is what we call a thread in the basic concept. Okay, so if you have about 1,000 people waiting for food in your restaurant, what happens is that if you don't have a lot of resources, or let's say stove or burner, what happens is that you have to prepare one person's meal at a time, right? So think about virtual trade as a magical idea or concept where you are, that gives you the ability to be able to prepare more than one meal or serve two customers at a time, or serve more than two customers at a time, right? So that's the whole concept of basically concept of virtual threads and virtual threads. Okay, so technically, what are threads? I think technically, so I just had a quote from Oracle that says that virtual threads are lightweight threads that reduce the efforts of writing and maintaining, debugging and debugging high throughput concurrent applications. Okay, so what basically that means is virtual threads are also threads, but they give you the ability to be able to bring a lot of great output. And also when you're debugging, you write less code and stuff like that. So I'll just go on. And from here, traditionally, what I explained earlier on, right? So you have the same source of energy. You have the traditional thread, and then you have the virtual thread. So you see that with the traditional thread, when you go to the kitchen, you only have one LPG gas connected to one stove. And in this case, it's not very efficient. So what happens is that you are not able to do a lot of things at the same time. You're not able to cook more than one meal at a particular time. So what you do is you with virtual threads, it gives you the ability to be able to do more. Okay, so let's say you have the ability to be able to add more burners to this particular stove. So what happens is that you'll be able to prepare more food, you're able to serve more customers. So that's one of the abilities that you see in virtual threads. Okay, right. So looking at an overview of the virtual threads, you see that we have so we can't do this without the hardware, right? So even though it's virtual, it's kind of like related to the hardware. So from the hardware perspective, we have the OS kernel where the threads are running from there. So threads at that level, we call them the platform thread. So threads that are created at the kernel side are managed by the operating system. Okay, and the virtual threads that we create are being managed by the Java runtime, or whatever language that you are using. You find yourself that it's using the runtime of that particular language or programming language. Okay. So with this, we are able to create a lot of virtual threads, and at one particular time, you find out that a virtual thread is being stuck or pinned to a particular platform thread. So I'll explain further as we move on. Yep. So let's just do some comparison and then let's see. So what do we see? So in terms of execution, when you're running a particular application or doing a particular task, you find out that the platform threads are being managed by the operating system. They are being created and managed by the operating system. But with virtual threads, it's being managed by the Java runtime, for instance. And then we come to the availability. Yes. So with platform threads, you have a very low availability. And this is very dependent on the available resource here, which is a CPU. So if you have a lot of CPU or you have high CPU resource on your machine, you find out that you have more availability. But if you, with virtual threads, with the same hardware, you're able to get a lot of threads or a lot of virtual threads, and then you're able to do a lot of tasks. So the availability there is very high. And then we look at resource overhead. So basically, resource overhead talks about you having extra time, for instance. So you have been given a particular resource to do some work, and you have exhausted all the resources. What do? How much more overhead or how much more resources do you need in terms of memory and then CPU? So with platform threads, you require an extra or a lot of resources in terms of CPU and RAM. With virtual threads, you either require no or very small overhead. And then we look at number of threads. So obviously, I'll be doing some demo, and then you will see that the number of threads, you're able to create more virtual threads than you can create platform threads on the same device. Right. So we move on. So where from virtual threads, or why does virtual threads come? What problems have you identified that we have to talk about virtual threads? Okay. So, yep. So as you can see from my screen, I have some code on my right and then some text on the left. So with this code, you can see that it's basically someone went to an e-commerce website and they try to purchase some items, and they'll put the items in the cart and stuff like that. So let's just go through this code, I think one after the other, and then let's try to identify any problems that comes up here. So with the first line, you could see that we are trying to query the user by name. So let's say at the back end, the front end, the person is done selecting their items and put them in the cart and then checks out. So behind the scenes on the back end, we get the user and then we try to find if the user exists. That's what we explained that by line one. So with line one, you try to create a database and find the user objects. And then you query after finding the user objects. That is basically you making a call to the database, right? So you make a request to the database, and then the processing at that particular moment is being done on the database. It means that your CPU has nothing to do with that at that moment, is not performing a particular task so long as your application is running. So it's basically just waiting for the database to get back. So in that case, the whole process is waiting for the database to get back. Then we move on to the next line, which is line two. You also realize that we also check in the repo to see if the user is also exists. If the user exists, we try to save the user and also making a call to the database. That as well also makes a call to the database. And you are basically just waiting for the call to return or for the database to tell you that, yes, it's done saving the user details in the database. Okay, so that moment to your application, your process is just waiting for response, and that nothing is happening at that moment. Then you move on to, you have to load a cart for the user. The user has submitted a lot of items in the carts, and you also have to look at load the items, and then that also is a database call, right? So you also just be waiting and not performing anything in your application. You are just basically waiting. And then we have from line 6 to line 9, which talks about the summing of the prices of the items in the cart. Okay, this is purely the operating system doing this job. So it's just doing some arithmetic operations, getting a very long stream of items in the cart, getting their prices and summing them. So this is being done at the CPU level. So CPU is basically doing these calculations, and at this particular moment, CPU is very busy doing some work, right? So it's no longer waiting for someone to give them the response and then they can proceed. Yep. After you're done with the calculation, you ask the user to pay. So there's a payment request is sent to the payment service, and you're basically waiting for the payment service to return a response that is successful. And if the payment service is taking 2 hours, 3 hours, 10 seconds, 20 seconds, 1 second, you are just waiting. And the CPU is basically not doing anything at that particular moment. It's just waiting for response. The same thing for the email server. You send an email after the payment is successful that, hey, customer or user, you purchase these items. This is the receipt, or this is the email to confirm your order. Your order will be delivered to you. Okay. So until you get feedback from the email service, you are still just waiting. So what have we noticed here? We realize that the code is easy to write. I mean, it's very easy to read. If a non-tech person sees it, at the time they run from the top to the bottom, they realize that it's someone trying to buy something, because there's a user, the person is trying to load cart, okay, the person pays, and the person receives an email. Okay, so this is easy to read, easy to debug. If something is not going on well at certain points, you can point straight that this is where the issue is happening. Okay, so what is the problem that you've identified? The problem you identify is that we are not using the CPU to its fullest, or the CPU is just it's underutilized. That is the problem that you identified here. And at a certain point, your process or your thread is basically just waiting for someone to respond. It's either waiting for the database to respond and not doing anything, and also probably waiting for the payment service or the email service to respond. And if they are taking longer to respond, your resources are there not doing anything. And you are just holding some resources or preventing other people from also using other resources as well. So that is a problem. Now, let me explain further. So with platform thread, what we have identified is that when you send a request to, let's say, a service or an HTTP server, what happens is that it connects to a platform thread on your machine or your service. So what happens is that if you have low resources in terms of CPU and RAM, and you are not able to provide a lot of thread, then that is it. So if your application is providing, or its application has the ability to create, let's say, 1,000 threads, and you are sending 150 threads you are sending 150 requests, then you'll be in trouble. It means that at a particular time, you can only serve 1,000 requests at a time. What happens to the 500 remaining? It means that they have to wait for threads to be fed up, and then they can also process their requests. In some cases, you can find that some of the requests are dropping off because they've been waiting for too long. Okay, so that is also a problem. So to further explain what I was demoing earlier on, in a typical request, let's say HTTP request, making a request to let's say, the payment platform. So programmatically, what do? You first prepare the payload, right? In preparing the payload, you create a JSON object, you put in the amount, you put in the user, you put in if you have to put in PIN or something else. So you put all those things, and then maybe you have to format something as well. You put all those things in the JSON payload. That takes about some small time, which is let's say it takes like 10 milliseconds. And then you send the request to the payment service. The payment service, at that particular moment, you're just waiting for the payment service to return or to respond back to you, and you're good to go. But let's say it takes longer, because that is not in control. That is not in your control. It's being controlled by an external API or external party. So if that external party is taking 20 seconds, 30 seconds, assume you don't have time on your application, then you are doomed. So that takes a very long time, or that might take a very long time. And at that particular moment, the CPU is basically not performing any particular task. It's just waiting for the response. And then as soon as the response comes back, maybe you have to analyze the response and determine whether the call was successful or it wasn't. So it is the problem that we spoke about earlier on, is what we see in red. If the third party is taking longer, it means that we are waiting. We'll be waiting and we'll be waiting until they get back. Okay, and we can't guarantee how long it take them to get back, and that is a problem. Okay, so what are the possible solutions? I mean, what are some of the things that was done, or some of the daily things that you do in your application to resolve some of this? I think the JavaScript guys who answer this a lot, because on the front end, you find yourself having to send a request to the server, and then you need to proceed to do other things. Okay, so if you have something in mind, you can put them in the chat. All right. So I'll just move on from here. So possible solutions, yep, in solving that, in an attempt to solve the waiting process, you trying to wait for a response before you move on. There were a lot of suggestions or a lot of implementation that were delivered. So in Java, one of the key ones that we look at is completable feature. We look at the completion state as well. The reactive programming, which is also being used by a lot of people. The async awaits also the JavaScript guys and the C# people to attest to that. So what is the problem with these possible solutions? Okay, the problem with these possible solutions is that it is hard to read, it is difficult to debug. In terms of how to read or write, let's look about callback hell. Callback hell is where you have a lot of nested callbacks. So you can have about 10 callbacks in just one code, or in just one code, you have a lot of callbacks. And that is very difficult to write and it's very difficult to read. It is a very popular term on the internet, so among developers. So sorry, I didn't have that up here, but if you check it up, you see that it's a lot of nested callbacks together, and it's very difficult to read and it's very difficult to write. If you have to keep adding, or keep getting a lot of callbacks, that is going to be very huge and it's very difficult to write and it's very difficult to read as well. Okay. And also, if you have this kind of callback or lambda functions written together, one of the things is that because it is seen as one bulky code, you can barely test components of it. Okay, so I'll show you an example. So in an attempt to solve this issue of processor not being used and stuff like that, these solutions were brought forward. These are the challenges that they are. So I'll just show you a sample with a computer feature, how it looks like, and then we'll discuss the challenges. Okay, so moving on, yes, so it's lambda in asynchronous programming. So this is an example of using computable feature API in Java. So the same code that we saw earlier on has been written this way so that we avoid the waiting and the waiting thing where we have to hold up resources or wait for someone else or external system before they reply. Okay, so here you can see that the user, we get the user, we check if the user is there. If the user is not there, we try to save, and then we move on. We try to load the cart, and then we try to sign the prices. We ask the customer to pay, and then we send an email. This is it. The sample code that we saw earlier on has been written with asynchronous programming, and this is how it looks like. So this obviously doesn't look simple compared to what we had earlier on. Okay, so it is difficult to debug, right? Because it's very bulky. You can't take just a component or a line of it and then you can debug. Okay, so that is one. It's also difficult to understand or read. Earlier on, you can obviously see it when you're going through. I mean, someone who's not a programmer can even look at it and try to tell what is happening in there. Okay. And like I said, with the unit testing too as well, testing components of it, this code looks like more like in one line or more like a bigger code or chunk all put together. And you testing components of it is going to be very difficult, right? So, so how does virtual thread comes in? Okay. So this is it. So let's go back to the first code where we had a very simple, we have simple layouts of code where we had getting the customer and we try to get the cart and all those things. Okay. So what happens? How does virtual thread works? Okay. So how virtual thread works is that as soon as a request comes to your service or you are processing something, an activity or a task in the virtual thread is being pinned down to a platform thread. Okay. So let's say in this case, the platform thread is called worker1 and it's being pinned down to it. So what happens is that in the next picture, as soon as the virtual thread detects a blocking activity, like say a DB call or an API request, immediately the virtual thread is being moved from this particular, is being disconnected from this particular platform thread. And then it's being moved from here to the heap memory. Okay, like we can see over here. So at this particular moment, this particular platform thread, which we call worker1, is very free. So any request coming into the application is looking for any new thread, can just pick up this thread and then use it. So what happens if the request comes back from the third party or from the database? So the virtual thread detects that and then quickly moves the virtual thread or quickly move from the heap memory and then back to the stack memory. So in the stack memory, it looks at any available platform thread so that it can pin itself to it and then it's to continue its work or its execution. So let's say in this case, it came back and then someone else is using worker thread or the worker one, which is the platform thread one. it comes and someone is using it or it's very busy. So it will look for the next available platform thread to work with. So this is it that we see over here. So this movement from the stack memory to the heap memory, and from the heap memory back to the stack memory is how virtual thread work. So in simple terms, look at it this way. So you have a bunch of requests that are blocking, and as soon as they are blocking, they moved into the heap memory, which is all this green virtual thread. So a lot of threads are blocking and they can be in there. So as soon as any of them returns, they come back to the native memory or the stack memory, and then they look for any available platform thread and attach itself to, and they continue working. Right. So moving on. So if you have implemented virtual thread, how do we implement virtual thread? So with the same code that we wrote earlier on, which is from here, this line 2 to the last but one line, you can see that it's the same code. We haven't changed anything. We haven't touched anything. So we are maintaining this readable code, just that we are wrapping it around an executable task where we put them in a virtual thread. So we wrap this around a runnable task, and then this is how we start our virtual thread, and we are good to go. So let's say when running this in a virtual thread, and this operation detects that it is a blocking activity, what happens is that it moves the whole virtual thread, this virtual thread that we created called virtual thread, it moves it from the stack memory to the heap memory. And then as soon as the database responds back, it brings it back so that it can continue the execution from this particular line, this second line. And then that continues like that, right, until the end of the program. So that's how virtual thread works. Now, we'll perform some demo and then we'll look at it. So my first demo is going to look at how a blocking thread is resumed on a platform thread. Okay, and then next I'll look at how many virtual threads that can be created. Okay. So let me start off by looking at how a blocking thread is resumed. So I'll change my screen to here. Okay. So we want to be able to know the movement if truly virtual thread actually moves to the heap memory and actually it comes back after blocking. So I wrote some code here, and basically I just start a virtual thread, and then I print the thread ID, and then after I'm done running as well, I also print the thread ID here. Okay, so this is my blocking activity. I'm deliberately sleeping about 100 milliseconds just to see that at the time that I am sleeping this thread, that is obviously a blocking activity. It's going to move the thread to the heap memory. And as soon as this particular call is returned, or as soon as the 100 milliseconds is up, it comes and then prints the thread ID again. Now, if it actually moved from a platform thread, we should be able to see that, right? So let me clear the screen and run this application. Yeah, so let me just zoom in this. Okay. So this, we can see that we created a virtual thread, and the virtual thread ID is 21, and it's running on a worker thread or a platform thread called platform 1. Okay, worker 1. And after it resumes after sleeping for 100 milliseconds, it's still run on that platform thread, platform thread 1. Okay, let me run this again. Let's see. Yeah, so after running it again, really, so the same virtual thread that we are creating again, so this time the ID remains the same. The ID is 21. So initially it was running on worker thread or platform thread 1. And then after sleeping for 100 milliseconds, it resumed on another platform thread, worker 2. So it didn't go back to use the worker 1. So in the first scenario, if you're not convinced that it actually moved and then came back, then this second example should convince you that the same platform thread 21 was initially running on the same virtual thread 21 was initially running on platform thread worker 1, and then after it blocked and then came back, it came to continue on worker platform thread 2. Okay, yeah. So The next one is looking at how many virtual threads that we can create, okay, compared to, or if we have a few platform threads, how many virtual threads can we create? So just let's look at an example of that. Yep. So this is my code. Let me reduce the number of threads that we can create. So I'm starting a thread. I'm starting this. We should be able to create 10 platform threads. And then we should be interested in seeing that how many threads are we creating, how many virtual threads are we creating, what is the time we took to create this number of threads, and then how many platform threads were used to create this particular virtual thread. Okay. So if I go ahead to run this, I'll bring this up a bit. Yep. So bring this up. Yep. So I configured 10. So we have 10 virtual threads. This took us 38 milliseconds. And then we only use 2 platform threads, right? So initially, if or before virtual threads came in, if you had created virtual thread, or if you had created a thread in Java, you'll be having, if you created 10 threads, you'll be having 10 platform threads being mapped that way. Okay, so let's see. Initially, I have 10. Let me increase it to 1,000. If I run this, I have 1,000 threads, virtual threads created. It was created 36 milliseconds. So this increased a bit. And then we only use 8 platform threads. It means that each of these 1,000 virtual threads were at certain points were being managed or were being pinned down to only 8 platform threads. So we made use of just 8 platform threads, and then we created 1,000 threads. So again, initially, if you have to do this using the traditional thread or the platform thread, you realize that you are going to use a lot of platform threads. So if you are using 1,000, you'll be having 1,000 platform threads. But with virtual threads, no way. We can create 1,000 virtual threads and still use 8 platform threads. Let me increase this to 100,000. That is huge. This was 36 milliseconds. So we have increased this from 1,000 to 100,000, right? And we are doing 491 ms. This is still less than a second, and we still maintain the 8 platform threads, and we're able to create this. So let me just try this to 10 million. This is 10 million. If we run this is the last one you're running. It's taking a while. Yeah. That should tell us that, yeah, there are lots of threads. But imagine creating this with platform threads. Let's see the time it takes to return. And if you have to create 10 million platform threads, that's going to take you a very long time. I didn't have enough time to demo that. Sorry, but this took us 13 seconds to create 10 million virtual threads. Okay, and still we were able to create 10 million virtual threads using 8 platform threads. So this is one of the abilities that virtual threads gives us. It enables us to create a lot of threads, give us, and from this we can see that it will scale and gives you more availability to your service or your program. Okay. Okay. So I'll just move on to my last demo, which is the use case in Spring Boot 2, 3.2. So when virtual thread was released, I think Spring Boot also a lot of platforms
Hello, everyone. Sorry, we think we have a couple of technical issues with Emil's internet connection at the moment, and across our team, we are working to try and get him back. It might take a moment, but please bear with us. In the meantime, you can let us know what of the demos has been your favorite so far, and make sure to leave any questions that you have in the chat as well. We're working really hard to get Emil back on stage. We're really sorry about this, but that is the nature of live events. Sometimes internet just drops for a moment or two. If we can't get him back, we will do what we can to wrap out today's session and bring him back for another session before the end of the year. But hopefully he should be back now in a moment or two. Feiji, do we have you still on the line? How are you doing?
Of course, I was really, really enjoying Emil's session. And for someone who's non-technical like me, I really love the kitchen analogy. Um, I mean, when I had virtual threads, I thought of like needle and threads, but like online, which is very wrong. But yeah, I'm getting to learn like a lot. Virtual threads actually help you be more efficient. And that's great. So I hope you guys are enjoying this as well. Please don't, be shy, ask questions. If virtual threads have helped you in the past, please, drop it in. If there's any place that you think, virtual threads, would work, let us know in the comment section or the chat box. So I believe we have Emil back. Welcome, Emil.
Thanks. Just some small glitch.
No worries. We have to get virtual threads in there in the back end of the internet. I'm just kidding.
Yeah. Okay. So my screen back.
Okay, so I'll let you take over.
Yeah, sure. Yeah, so sorry about that. Yeah, so I got to the last part where Spring Boot was also doing some work. I think a couple of platforms and frameworks and tools are also looking into it or updating their repos to include platform threads. And Spring Boot did a very great work to release 3.2 last week to include platform thread. So I'm just going to demo to you how Spring Boot made use of it. It was just launched last week as well. I think exactly a week ago that they released it, and I was able to put something together to show. Okay, so I'll go to my code, and this is it. So basically, for you to be able to implement, let's say you are exposing an API or you're exposing a route that someone has to call, you don't have to do much. Spring Boot gives us this ability to be able to configure this particular this configuration or enable this configuration in the application properties file. You have to do spring.threads.virtual.enable true. Okay, and then you are good to go. It's the only thing that you have to do. You don't have to do much. You don't have to do anything else. Okay, so let's say I have enabled virtual thread in my code, and I need to expose some routes. So I expose this route called product. And basically what I do is I create some random products and then try to save in a database. For some reason, my database is kind of very fast. So you might not see the blocking, or it's very fast such that it quickly returns on the same thread. Okay. So for me to be able to demo this properly, so that I don't keep running it for a very long time just to show you that it came back on another platform thread, I prolong the blocking to, let's say, some 10 seconds. I can reduce this, but let me keep it like this. And then so at the time before I save the details and then save in the database, I printed a thread ID just like I was doing in the previous demo. And then after I have blocked make the database call and then block the thread for a while. I printed the ID again for us to see that it's actually went to the heap memory and came back on another platform thread. Okay, so I'll just go ahead and then run this. Okay, so I just clear the screen and I'll test this from Postman. Okay, so I make a call and then I have this. Okay. So what I see is I see start of thread 1. I'm printing the thread ID just so we see what is going on. So let me just do Control F to look for it. So this is start of thread. This is the thread ID that I created or just to track. This is a random session ID I created to track the threads, right? So this start of this thread ID, the thread ID is called, or the number is, or the ID is virtual thread 43, and it is running on worker thread 1. And after it resumed, or after resuming from sleeping, it still continued on worker thread 1. Okay, there are not too many requests, so I can probably guess that that's why it probably didn't move to a different worker thread. When it came back, all the worker threads or the platform threads were free, so it continued on 1. Okay, so what I'm going to do is I'm going to make multiple calls, and let's see the scenario. Multiple calls in a typical environment will be that a lot of servers or a lot of clients, a lot of users making requests to your application in real time. So this is it. I'm going to make a lot of requests to it in Postman. It is not heavy, but at least it demos what we want. So if you can see on my left, you will see that I'm going to send a lot of requests by sending this multiple times. Send it, another one. So let me send a couple of them. Let me send so many of them. So you can see on the left side, I'm sending a lot of requests. This is very manual, just pardon me. Yep. So let's go back and then let's pick a random thread. Let me pick one session ID. So let's look at this. So this is start of thread SAJ9G. The thread ID is 71. It started on worker 1, which is platform thread 1. Let's look at when the thread ended. When the thread ended, end of thread, the same session ID, the virtual thread is 70. We realize that it moved from platform thread 1 to platform thread 6. So yes, so you have this happening, a lot of moving and a lot of freeing, a lot of thread, the platform thread, so that other virtual threads can also make use of. So this is going to scale your application a lot. Okay, so assuming that I turn this virtual thread capability off here, and then I rerun this, notice that here the name of the thread is virtual thread, right? But after disabling the virtual thread ability, what does the name go to? Okay, so just clear this and then make a request. I don't even need to make a lot of requests. Sorry. Yeah, so let's see what's happening here. So I see that start of thread. So you notice that the thread naming changed. Okay, sorry, it's over here. The thread naming changed. Initially, it was virtual threads, and now it is thread. So if you enable this in your logs, you will see virtual thread. If you disable it, you see virtual thread. So you don't necessarily need to disable it. If you don't need it, you can take this entire line off, or you can keep it there for easy configuration sake. So you put it to false, and then you have this. So you can make a lot of requests here. When you do this and you have about 1,000 requests coming in, it means that they're going to use 1,000 platform threads. That's heavy. But from the demo we did earlier on, you could testify that we can have 10,000 platform threads actually running on 8 platform threads. We don't have to use enough resources, but we are going to achieve the same thing. Okay. So this is the demo of what Spring Boot has introduced. And I think it's pretty cool. We can all join it. So let's move on. So that ends my programming demo. So I'll move on to the next slide. Yep. So how does it affect your existing code? Okay. So you have been coding already, you've been doing your code, you've been doing your programming and things like that. But I mean, you want to migrate. What do you have to do? Do you have to do a lot of things? This is it. So I mean, the community is ensuring that we don't do much or we don't do plenty things. So look at this as your code, your previous code. If you're using Jakarta EE or Quarkus, what happens is that you have this route, your route does some work, and you specify the route, the path, and then a few configuration things you need to expose on the route. So this is the old one, which you can see on your left. And then the new implementation is what you see on the right. So the same code, you just have to ensure that certain things are present and you are good to go. So if you're using Jakarta EE, just ensure that your Jakarta, you have upgraded to the Jakarta platform 11. So at the time of this presentation, the latest version was Jakarta EE platform 11. So just ensure that you have that upgraded. And obviously, it was the virtual threads was released, or the stable version was released in 21. So you also have to ensure that you have JDK 21 installed. If at later time after this presentation, there's a high version, you can install that as well. So in your code, what do you have to do after ensuring that you have this things configured in your code? What do you have to do? All you have to do is just add this run on virtual threads. Run on virtual thread, you are good to go. So you see that you don't have to do much. Okay, you don't have to wire this up in some form of asynchronous programming, do a lot of it to make your code hard to read, hard to understand. Just keep your code, maintain your code, and allow virtual threads to do the rest for you just by putting this over here. So the same if you're using Quarkus, what do you have to do? You have to ensure that the version is 2.10.0 that's final. Just ensure that you have this at the time. Again, at the time of this presentation, this was the latest version, and obviously you should have the JDK 21 running or higher. Yep. So the same thing for the Quarkus too. You just have to put in just this one line of code. So if you have your existing code, what you don't have to do much. Just spend some few time and let's put this annotation over here, and you are good to go. Good. So you move on to the Spring Framework or Spring Boot, or if you are using Apache Tomcat as well. What do you have to do? The same way, when you look on the left, you see your old code. And how do you transform this? So let's look at it. So you have to obviously upgrade your Java version to 21 and above if newer versions come. You don't have to do any changes to your controller. All you have to do is add two beans to your application, and then you're good to go. So you could have a configuration, or you could have a class and as component annotated, and then you have put in this your beans, and then you are good to go. You don't have to do much. So you don't have to. So once you add this to your project, you are good to go. You don't have to add any implementation to your controllers and things like that. Okay. But if you would prefer to move from your Spring Boot version, whichever Spring Boot version you are using, for instance, and you want to move to 3.2, then that's sweet. All you have to do is just configure it in the application properties, and then you're good to go. All right. So obviously, it's a bit of a thing to have virtual threads, but what do you do and what don't you do? Okay. So let's see. I have a very important note here. It says that it is more expensive to run a task in a virtual thread than a platform thread. Yes, it's one of the key things that has been mentioned over and over since it's been launched. And why do we see it that way? Okay, so I explained how virtual thread works, and it works by moving tasks from the stack memory or detaching a virtual thread from the platform thread, and then move them to the heap memory. And now if it is unblocked or whatever is blocking it is released, it actually moves the virtual memory, the virtual thread from the heap memory and then back to the stack memory, and it actually looks for a platform thread. So that movement back and forth from the stack to heap and heap to stack is actually expensive, right? It's not free. There's something going on, right? So that is why we say that it is expensive. But with platform threads, you don't do that. So why then do we have to use why then do you have to use virtual threads? Okay, the advantage of it is that it is extremely very low when you are performing blocking activities. Okay, so just imagine you are calling an API. The API is taking 60 seconds to respond or 40 seconds to respond. That is a lot of time, right? If you have 10,000 of these threads, 10,000 requests, and they all have to store like that, virtual thread is best, is going to ensure that the thread is being released or the platform threads are released for other virtual threads or other requests to also handle. But if you are doing this in a native thread or you are doing this in a platform thread, all your threads are going to get used up, right? So we deem it that is very, very low. It's very, very performance high when you're using virtual thread. So we look at the pros and cons, and then we can say that, okay, there are some things that you don't have to do. There are some things that you have to do. So what do you do, or when do you use virtual thread? So you should use virtual threads if you have blocking calls. Okay, you have HTTP, you are making a HTTP call in your application, you are making a DB call in your application, you are performing some IO operations in your application. You should do that. And also, if you are making a lot of calls without leveraging on a particular pool, let's say you are making a lot of HTTP requests and you are not reading from, you are not creating you're not getting your client from a particular pool, and you are just making your calls, I think you should consider looking at virtual threads. Also, virtual threads can improve your response time. Yes, so if you have a lot of requests hitting your application, then some is pinning on virtual threads and others, and you have the request keeps increasing. The request keeps increasing. Yes, you have a lot of virtual threads to serve you, and then your application will do well. Yeah. So if you actually run, let's say, a load test on your application, you will see that your application is doing very well, right? So what don't you do? So things that you shouldn't do, don't run tasks that are doing in-memory computations. So for instance, if your application is not doing a blocking call, you are just making some addition, like summing some items or calculating some calculation, processing some string, you don't need to use virtual thread because you are not blocking anything, right? So don't do that. Okay, so if you're also doing some form of parallel streams without any blocking activities, then you also don't need to use virtual threads, right? If your entire application calls, if you have entirely all your native calls in virtual thread, it will pin down the virtual thread to the platform thread. Yep. So if you are, yes, so what you are saying is if you have in my earlier example, if you are doing just some calculations, if you are doing normal processing, that is not blocking. What happens is that the virtual thread, like the example I showed you, the virtual thread is now pinned to the platform thread, and you're actually wasting that. Okay, it cannot be released because there's no blocking activity, right? So lastly, don't run heavy activities on virtual threads if it doesn't really include any form of blocking. Okay, so you decide that you are going to do something heavy and then you use virtual threads. It's not the best practice. Okay. Yep. So from this, I think you guys have seen a couple of advantages that we have seen or advantages I've demoed through my theory presentation. Yes, you can see a couple of advantages. With the disadvantages, yes, virtual thread got here like 2 months ago, or maximum, yeah, I think we said somewhere in September. Like that's when the stable version was released. And people are still learning. We are all learning. We are all following it quietly. There might be vulnerabilities. There might be bugs. There might be new things that are coming up and stuff like that. So it's a learning curve for all of us. And backward compatibility is what we are also looking at. If you have to, I mean, use your older version of Java to run virtual threads, that's not possible. Yep, and there are quite a number of things as well. So I think the resource still depends on available resources. Yes. So even though we are saying that it's virtual threads, it's still dependent on the hardware that's available. So you can't create like trillion virtual threads on a very small CPU resource. I mean, you can't do that, right? So it's still dependent on the hardware, even though it gives you more throughput. Right? Yeah. So what does the future looks like? So more tools are implementing it. So you have a lot of tools and libraries that we use in our application. You might not know some application is spinning some thread behind the scenes and doing some stuff, right? So a lot of guys have jumped onto virtual threads and trying to implement virtual threads in their libraries. So if you're worried about these platforms, I think you should worry less. Also, all these frameworks, Spring Boot just released DS, and they are still working on improving it. I think Jetty, Tomcat, all these guys are actually doing their best to bring virtual threads on board. So it should be good in the future. And so just to go back to the possible solutions, we saw reactive programming, we saw some asynchronous programming, and things like that. And that was the reason why we had to bring virtual thread to combat their challenges. And so one of the Java architects mentioned that I think that Project Loom is going to kill reactive programming. And if you ask me, yes, with reactive programming, you have to do some form of adaptation, change your code a bit and stuff like that. But with virtual thread, just keep your code and you are good to go. So yes, Spring Boot released the autoconfig, which I demoed, and we are going to get a lot of increasing support. Yes, I think I see a lot of people jumping on it, and so that is good for us. Okay. All right, so I just added some reference to it, and then I think this is it. If this is shared, you can watch the documents. Thank you. The bigger question is, with this simple implementation and things that I just demoed, I mean, you don't have to do much work. Would you want to use virtual threads? Do you think it's a good thing that you want to jump on? All right. You can put your answers in the chat. Thank you very much. I'll wait for you.
Awesome, Emil. That was amazing. Thank you so much for that amazing presentation. The demonstration actually was top-notch because you went deep in. And I mean, thank you for sharing your time. For those on YouTube, we see you. We see your comments and the emojis. Thank you for also sharing your time with us. I don't know if we have any questions. We could take one question because we are at time. It was such an amazing presentation, and this will be shared after this call. But do we have any questions for Emil? Feel free to drop it on the Q&A tab beneath, or also in the YouTube chat. We'll be happy to answer just before we wrap it up. But brilliant talk, Emil. This was really great, and we're happy that you took out time to share your experience with virtual threads.
So,
I think you did an amazing job, because questions on YouTube, I think everyone is just singing your praises. So thank you so much, Emil, for this. With that, we'll be wrapping up this session. Let's keep this conversation going, especially with virtual threads. This shouldn't be, the last time we stop this conversation. We go on Andela chat, on Circle, and talk about how you've been using it. If this is the first time you've heard about it, please, let us know. If you're having any challenge, it's Emil is sure to be able to support you there, because he's a master at virtual threads. So, Emil, I don't know if you want to, speak about how we could connect with you after this call. You shared several let's say links on LinkedIn, on GitHub, on Andela chat. How could we reach out to you if we want to connect with you?
Yeah, so you can connect with me, I think, on LinkedIn. I think it's my full name, Emil. So when you search Emil Nakaba, I think I can surely tell you I'm the only one who will come up. You can easily find me there. And also, I think you can email me if that's very necessary, email.jakabo@gmail.com. That should be okay. All right, thank you.
Awesome. And thank you for your comments. Fad says it's time to roll with virtual threads. Yes, it is. And I don't know if we could just take this before we wrap up. There's a question: are threads in Java Fad different from other programming languages?
Yeah, so no, they are not different. Okay, so it basically boils down to the platform threads. So if you spin a thread in any language, it obviously pins it to the platform thread. It's the same technology that is used across all platforms or languages.
All right. Thank you so much, everyone. Thank you for joining once again. And we'll see you at the next workshop. And we'll be learning something new. So stick around for more information. Thank you so much for being here and enjoy the rest of your day, guys. Bye.